All right, welcome back, everyone. Today is July 5th, and it's raining out today. A lot of rain. I was at my job this morning and I got soaked. So I came home and I thought, what better thing to do than the big P, man, the big probability. So without further ado, let me stop talking and let's get into the question, all right? Here's today's question, and I just want to preface this question. I would classify this question as a mind. There we have it. That is how I would classify this question. After spending quite a bit of time on it and trying to record this video once already, I feel like I have the right to classify it as this type of question. So without further ado, for the second and real time, let's get into it. A chess tournament has 2 to the n players with skills 1 greater than 2 greater than 3 greater than ... and then so on until the 2 to the nth player. It is organized as a knockout tournament so that after each round, only the winner proceeds to the next round. Except for the final, opponents in each round are drawn at random. Let's also assume that when 2 players meet in a game, the player with better skills always wins. What's the probability that player 1 and player 2 are going to meet in the final? Okay, so if you like, you can pause the video and think about this, but I'm just going to get right into it. The way we want to think about this is the probability that player 1 and 2 don't meet before the final round, right? Because isn't the probability that they meet in the final the same as the probability of them not meeting in any round before the final, right? So that's up to round, n minus 1 if there are n rounds. Right? So these are equal. Them meeting in the final is the same as them not meeting in any round before the final, because if they were to meet before the final, it would, end the experiment. The experiment would be off because they would have met and now they can't go against each other in the final. So with that in mind, I think a good next step to think about is how many rounds are there? Okay, and to do this, I've already started writing it out, but you can kind of see. To do this, we're going to use logs, okay? So if there are 2 to the n players, and the players are getting divided by 2 each time, we're basically just saying how many times are we multiplying 2 by itself to get to 2 to the n, which is the same as log base 2 of 2 to the n, which is equal, of course, to n. Okay, so this is saying how many times do we have to multiply 2 by itself to get to 2? I'm sorry, not by itself, but how many times do we have to raise 2, or to what power do we have to raise 2 to get 2 to the n? And of course, that's just n, right? All right, so let's keep it going. We've got some good momentum here. What else can we say about this? Well, I always like to look at the start and the end of the question. Okay, and at the end of the question, we know it's just going to be one player, and that's going to be player 1, because player 1 will always make it to the end round. Just think about it logically. Player 1's never going to lose, not even in that final round. So it's a guarantee that player 1 makes it to the final round, and player 1's going to be against some other random opponent, probably like 2 or 3. Well, actually, probably only 2 or 3, actually. I'm not going to get into that, but player 1 is going to be against another opponent in the final round, okay? All right. So, well, actually, no, not only. You know what? I'm not going to get hung up on that. We can talk about that in another video. But that's what the end looks like, okay? So what does the start look like? The start looks like there are 2 to the n players, right? And it's going to get split in 2. Okay, it's going to get divided by 2 because everyone is going to pair up with another person. Okay, there's going to be this many groups of 2, and so half of these people, half of this 2 to the n, is going to get chopped off after that first round. Okay, but remember what we said? We wanted the probability that we don't go against player 1 in any of the rounds before the final round. So what's the probability we don't go against player one in this first round? Okay, let's think about this. Switching colors. So in this first round, we pick player one with a 1/1 chance, right? We're just selecting player one. So your probability of being paired with player one is going to be 1 over all of the remaining players, which is how many? 2 to the n minus 1, right? Minus 1 because we're just not including player 1. So this is the probability that you get paired with player 1. So then the probability you don't get paired with player 1 is the complement of this, or in other words, is 1 minus this, which if we think about would be 2 to the n minus 1 over 2 to the n minus 1 minus 1 over 2 to the n minus 1. Okay, and that's just going to be 2 to the n minus 2 over 2 to the n minus 1. Okay, so this then is the probability that you are not getting paired with player one in that first round. Okay, this only is good for the first round. So as I like to say, let's just keep it pushing, right? Let's keep it pushing. Let's keep the momentum going. Okay. What about the second round? I want to bridge into the second round now. And for that, I'll use a different color. Okay. So now we're in the second round, and how many players remain? There are only 2 to the n minus 1 players remaining, right? Because we chopped off half. That's what this is saying. 2 to the n minus 1 is half of 2 to the n, okay? So this is how many players are remaining. And now let's think about it again, right? Your probability of getting paired with player 1 is, is not that. Probability of getting paired with player 1 then is the 1 over 2 to the n minus 1 minus 1. And subsequently, like we did earlier, the probability you do get paired with player 1 then is 2 to the n minus 1 minus 2 over 2 to the n minus 1 minus 1. Okay, so this is the probability that in the second round you don't get paired with player 1. But not just that. This is the probability that in the second round you don't get paired with player 1 given, very important that we are using conditional probability here, right? Conditional probability is the big term today. So important for solving this question, okay? This is the probability you don't get paired with player 1, given that in all the rounds before this one, you also did not get paired with player 1, okay? So we're going to define an event now. Now that we have like a pattern, I want to define our event. And this is also important. So I will switch colors once again, okay? So we're going to let EI be the event. So E sub I is the event that we don't get paired with player 1 in round I, given, this is so important, given that we did not get paired with player I in, with player 1 in any of the rounds prior to round I. Okay, so let me just make sure I did that correct. E sub I is the event that we don't get paired with player 1 in round I, right? Given that we did not get paired with player 1 in any of the rounds prior to I. And let's look at like why that is important, okay? So basically, what we're looking for is the probability of E1, right? And E2, and maybe you see where I'm going with this, and E3 and I won't do another one, don't worry, all the way up through en minus 1. Why n minus 1? Well, do you remember how there were n rounds? And the only rounds we care about are all the rounds leading up to the final one, which is n minus 1 rounds. So basically, we're looking at the probability that we don't get paired with player 1 in round 1, that we don't get paired with player 1 in round 2, given we weren't paired with them in round 1, that we don't get paired with player 1 in round 3, given we weren't paired with them in 2 and 1, and so on, up until that final round. So why is this important? Okay, this is important because we can dip into our probability tool bag and use one of our tools, namely, we're going to use the multiplication rule, okay? Because we're looking at the intersection of all these events. We're going to say that the intersection of these events is equal, okay, to the probability, you know what, I'm going to get rid of that first bracket because it's useless, is equal to E1 times probability of E1 given, I'm sorry, E2 given E1 times the probability of E3 given E2 and E1, okay? And don't you kind of see what's happening here? This is kind of just the same thing as multiplying them because probability of E1, you know, doesn't really rely on anything, but we already included the given E1 in the probability of E2. So this is sort of just the probability of E2, right? Because we already said probability of E2 is just the probability we don't go against player 1 in in round 2, given we didn't go against them in another round. And so that this E1, this given we didn't go against them in the first round, is already included. And same thing here. This is kind of just probability of E3. So you see how we're kind of actually just multiplying now? We're just multiplying probability of E1 times the probability of E2 times the probability of E3 and so on up through E of n minus 1. And so what does this look like in, you know, condensed form? Okay, I'm going to go back to blue. I liked blue. So in condensed form, this is a multiplication from the first round, okay, which I'm going to explain why it's n here in a second. Well, let me start like this. It's a multiplication, okay, of this equation for the probability, the conditional probability that we derived, right? Do you remember this from the beginning of the question? Well, here's where we use it. See how we start with n? We start with all the players. This is the first round. And we're going to that second to last round. Well, wouldn't the last round just be 1? But we don't want to go to the last round, right? So we're actually going to go to I equals 2. And so we're multiplying this out by itself from I equals 2 to n. And you know what? This should be an I. Okay? So it's the product of all of these. Okay? And we can still do more to solve this problem. It's not over yet. And this is where I kind of think it starts to get into the mind F territory because we've been doing probability, but now it's going to force us to exercise a lot of our other skills. Okay? It's going to force us to exercise a lot of our other skills as well. Okay, so we're going to start by simplifying this expression here, right? This 2 to the I minus 2 over 2 to the I minus 1. And what we're going to simplify this into is just 2 times 2 to the I minus 1, right? That makes sense. Minus 1 over, and just keep the bottom the same. 2 to the I minus 1. And now what we have to realize here is that this piece here and this piece here, look very, very similar, right? So we can call them something, okay? We can maybe call them A sub whatever the exponent is, right? So we could probably call this one A sub I minus 1, right? And maybe we could call this guy down here A sub I. And when we do that, it simplifies it even more so that now this is really just, 2 times this piece over this piece, okay? So let's look at how that summates now. So the first piece is 2 times, and then 2 minus 1, since the first piece is a 2. 2 minus 1 is 1. So we'll call this A sub 1, and then it's just going to be over, let's see here, right? 2, it's going to be over A sub 2, okay? And this is going to go on, right? The next piece is going to be 2 times A sub 2, right? Over A sub 3, right? And the next piece, just so that we really nail it in, is going to be 2 times A sub 3 over A sub 4. And we're going to multiply that a bunch of times until we get to the n, right? Until we get to n. And the last, it would be multiplied by the last part, which would be 2 times A sub n minus 1, right? Because when we plug that n into the I, it just becomes n minus 1. And we know that the one on the bottom is always 1 bigger. So the one on the bottom would just be A sub n, right? And let's look at kind of what's happening here. We see this A sub 2 crosses out with this A sub 2. This A sub 3, I'll do it in red actually. This A sub 3 crosses out with this A sub 3. And we can imagine that the same thing happens for the A sub 4. And we can imagine that right before this term here, it would also happen for this A sub n minus 1, right? So what we're really left with is a 2 in each part, and this A sub 1 over A sub n, okay? And so what does that equal to? Well, how many times are we multiplying 2? We're multiplying 2 n minus 1 times, right? Because if it was n times, this would be a 1 here, but this is a 2. So we're multiplying the 2 n minus 1 times, so it's 2 to the n minus 1 power, and it's multiplied by A sub 1 over A sub n, right? And what is A sub 1? Well, A sub 1 is A sub 1 is equal not the whole thing, right? But just the A sub 1 is equal to 2 to the 1 minus 1, and A to the n is equal to 2 to the n minus 1, okay? So then what we have here is just this piece here multiplied by this, right? And so that gives us a final answer of 2 to the n minus 1, this piece here, minus 1, because 2 minus 1 is 1. Or I'm sorry, no, not minus 1. Just that, over, okay, over 2 to the n minus 1. Not in the exponent, but just by itself. And this is our final answer for the probability. What was even the original question, man? The original question was the probability that player 1 and 2 meet in the final. This is the probability that player 1 and 2 meet in the final when we start with n, 2 to the n players. All right, thanks very much.